acid, we have properties of carboxylic acid. Properties of carboxylic acid are divided into two parts. One is all about physical properties, and secondly is all about chemical properties. But for today, we just want to talk about physical properties. Physical properties is what definitely we can see or we can test without getting into chemical changes. So we are having physical properties and chemical properties. But today we just want to talk about physical properties. Physical properties, we are having four things to discuss. One is all about physical states. The states of these carboxylic acids. It was determined experimental that, and it was determined experimental that the physical states of these carboxylic acids can be determined by facing out the first four members of the homologous series. Means the first four members of the homologous series are liquids, and the rest are not liquids. So if now you're talking about the methanoic acid, the first member. The second member, butanoic acid. The third one is propanoic acid. And the fourth one, that is butanoic acid. Means methanoic acid, ethanoic acid, propanoic acid, and butanoic acid are in liquid state. So the first four members in the homologous series are liquids. Means these four carboxylic acids are liquids. That is very important. And that is all about physical state. And when it comes to the smell, now the first three members have sharp smells, like that of vinegar, like perfumes. The smells of perfumes, it is because of what we call it, the first three members. Now, first three means methanoic, ethanoic, and propanoic. These have got a sharp smell. It is just like perfumes. So this is very important to understand. And once you take a curve, the curve of an orange, these have got this smell. It has got a sharp smell. So that is all about, we can say, the first three members have sharp smell similar to that of vinegar. And the rest means the members with 4 and more carbon, with 4 carbon and more, have got unpleasant smells. Means, if now you are talking about butanoic acid, pentanoic acid, hexanoic acid, heptanoic acid, octanoic acid, decanoic acid, nonanoic acid, means these have got unpleasant smell. But the first three members, that is methanoic, ethanoic, and propanoic, have got sharp smell. But for those who are having 4 carbons and more than 4 carbons, they have got unpleasant smells. Example of those, we are having butanoic acid, pentanoic acid, hexanoic acid, heptanoic acid, and so forth. Then, the third one is all about solubility. Solubility means alkanoic acid with lower molecular mass, they dissolve completely into water. Means for methanoic acid, ethanoic acid, and propanoic acid, when they are dissolved into water, they dissolve into completely to form other things. So they are dissolved into water completely. But for those only which have got lower molecular mass. But for those which are with higher molecular mass, they cannot be dissolved completely. They are partially dissolved into water. So that is the solubility. That is all about solubility of those, what we call it, carboxylic acid. But also, lastly, we are having boiling and melting points of carboxylic acid. this point is very important to understand. Carboxylic acid have higher melting point and boiling point compared to the corresponding alcohol. Means, if now you are having methanoic acid, this is methanoic acid. And also, you are having methanol. This is methanol. This is the alcohol, and this is the carboxylic acid. Now, the boiling point of carboxylic acid is higher than or is greater than to that of an alcohol. So, means what? If this is 50 degrees Celsius boiling point, this is less than this one. Means it may be 40 degrees Celsius. This is an example. Means the boiling point of that of alcohol is lower than that of carboxylic acid. In other words, if now you're talking about carboxylic acid, have higher melting point and boiling point compared to the corresponding alcohol. Means the boiling point of carboxylic acid is higher than that of an alcohol. Example, if now you are talking about an alcohol with one carbon and an alcohol with one and carboxylic acid with one carbon. Carboxylic acid must have higher boiling point than an alcohol. The same applies if now you are talking about ethanoic acid and then you are talking about ethanol. Both of them have got two carbons. These have got two carbons, and also these have got two carbons. And that is why we say corresponding alcohol. Means the carbon atoms, the number of carbons must be equal. Even though number of carbons are equal, but the boiling point of carboxylic acid is higher than that of alcohol. So this is the point, the meaning of this point. Means the carboxylic acids have higher melting and boiling point compared to the corresponding alcohol. So you can be given a question. Compare the boiling point of ethanol, ethanoic acid, and ethanol. And why does it happen in that way? The boiling point of carboxylic acid increases with the increase in molecular mass. So sometimes you may be given, this is the ethanoic acid, this is propanoic acid, this is methanoic acid. Then you are having ethanoic acid. Then you are having propanoic acid. Now you've been told, compare the boiling point between the three acids. The one that have got higher molecular mass, or in short, the one that have got more number of carbons than the other is the one that have got more boiling points. Now, this is propanoic acid, and therefore, this is less than this one. And this is less than this one. Means the boiling point of propanoic acid is greater than that of boiling point of butanoic acid, ethanoic acid. And the boiling point of ethanoic acid is greater than that of methanoic acid. Why? Because there is a gradual increase or decrease in molecular mass. And that is why we say the boiling point of carboxylic acid increases with increase in molecular mass. Means the carboxylic acid with more molecular mass have got higher boiling point or melting point compared to the carboxylic acid with less molecular mass. Example, if you look at here, we are having carbon, 2 carbons, but here we are having 3 carbons. Means the number of carbons here are increasing and the number of hydrogen also are increasing. Now we expect the molecular mass of this one, propanoic acid, is greater than the molecular mass of ethanoic acid. And therefore, the boiling point of this propanoic acid is greater than the boiling point of ethanoic acid. simply because these have got higher molecular mass compared to this one. And that is the point that the boiling point of carboxylic acid increases with the increase in molecular mass. And that is why propanoic acid have that high boiling point compared to ethanoic acid. And ethanoic acid have that high boiling point compared to methanoic acid. This is the point that refers to this one. So sometimes you may be told that now compare the boiling point between propanoic acid, ethanoic acid, and methanoic acid. To compare means to give the difference in their boiling point. As I said, these have got high boiling point. And also you may give the reason why is it have that high boiling point. Because the boiling point of carboxylic acid increases with the increase in molecular mass. This propanoic acid have that high boiling point, high molecular mass, and that is why it have that high boiling point. That's all about, we can talk about the physical states, the physical properties of the carboxylic acid. So you may be asked to compare the melting point and boiling point, or to give out the physical states, or smell, or solubility. As I said, alkanoic acid of the lower molecular mass dissolves completely in water, but the rest they dissolve partially in water. So that is all about what we can say, physical properties of carboxylic acid. Chemical properties and physical properties. Chemical properties, we are having only two things here to discuss. One, we are having reaction with sodium oxide. This is basic in nature. This is basic in nature. This is basic in nature. Now, the reaction between base and the acid is called neutralization. Now, when carboxylic acid reacts with sodium oxide in a neutralization reactions, that is the reaction between acid and the base. Actually, the result is salt and the water. This is how actually we do it. Example, if now the reaction between sodium oxide and the carboxylic acid, the result is salt and water. As you may see here, this is the ethanoic acid. This is an ethanoic acid. When this ethanoic acid reacts with what we call a sodium oxide, this is base. They produce salt. This is salt. That is sodium ethanoate. This is produced when there is a reaction between sodium oxide and ethanoic acid. Means the reaction between acid and base, the product is all about salt and water. That is why here, ethanoic acid, when we react with sodium oxide, what is formed is called sodium ethanoate, and this sodium ethanoate is salt in nature. And also, this is what we call it water. So the production, the results of the products, when the sodium oxide reacts with the ethanoic acid, they form what we call it sodium ethanoate, which is a salt, and also water, which are a product when the acid and base get together. The same applied, even if now you got maybe propanoic acid. This is propanoic acid. When propanoic acid reacts with some kind of the base, let's say it is potassium oxide, to produce, we definitely, this will react with this one. This will get together with this hydrogen to form what we call it water, then plus. This is the potassium ethanoate, propanoate, that is CH3, that is CH2, then it is this one, then this is potassium. This is how it is done. So this is the salt, and this is the water, and this is water. So the reaction between acid and base is all about production of salt and water. And this reaction is called the neutralization reaction. And the second chemical property here is the reaction with alcohol. Means when alcohol and acid get together, the reaction between acids and alcohol, they react to form what we call it esters, and the process is called esterification. So when you look at this one, this is the ethanol. This is the ethanol, which is alcohol in nature, and this is the ethanoic acid, which is ethanoic acid, which is acid in nature. When acid and ethanol get together, means we are looking together, we have alcohol plus acid. The result is what we call it ester. Now, ester is produced when there is a reaction between alcohol and acid to form what we call it ester. And if that is the case now, this is an ethanol and this is ethanoic acid, means this will get together with this one to form what we call it water. Now, water is formed when the ethanoic acid and ethanol get together to form what we call it water. Now, water is produced. Then, the reaction between ethanol and this one, this get together and form what we call it ester. That is, it is here. So, this is it is ester. Now, this is the result between alcohol and acid. When they get together, they form what we call it ester. Now, ester is definitely formed after the reaction between alcohol and ester, and the reaction is called esterification. So these are our two, esterification. Now, these are our two properties, chemical properties, in which now carboxylic acid can undergo. So the first one we have said, it is called neutralization, means the reaction between acid and base to produce salt and water. And that is an example of showing it here. And the second thing I've said, it is called the esterification, means the reaction between acid and alcohol to form ester is called the esterification. So these are the two reactions that we have to discuss when we are just talking about chemical properties of carboxylic acid. So this is all about chemical properties of carboxylic acid, and we are having two chemical reactions on how now this can react. But also we have so many things. Example, maybe we can also discuss how this carboxylic acid are formed. Example, alcohol can be of alcohol, that is alcohol to carboxylic acid. Its other chemical properties means carboxylic acid can be obtained from alcohol, means it is oxidation of alcohol. Oxidation of alcohol. And we know that when alcohol is oxidized, then, example now we are just talking about ethanol. When ethanol is oxidized, means the reaction of this is oxidation. Now, there is a direct production of what we call it carboxylic acid, that is the ethanoic acid. That is ethanoic acid. But this cannot happen until it passes through to what we call it an intermediate product, which is called ethanol, which is called aldehydes. Now, before it reaches to the carboxylic acid, there is a production of what we call it ethanol, that is aldehydes, and that is an intermediate product which is formed before it is being oxidized to what we call it carboxylic acid. So, in short, oxidation of alcohol to carboxylic, oxidation of alcohol to carboxylic acid. This is done. Example, we are having ethanol. This is the ethanol. It is oxidized to form what we call it. It is being oxidized in the presence of potassium permanganate. This is oxidized to form what we call it. It is aldehyde. This is the alcohol. Then it is oxidized to form what we call it aldehydes. This is ethanol. This is ethanol. It is only produced. This is ethanol, which is an aldehyde. This is the aldehydes. Then this aldehyde is then oxidized to complete formation of what we call it carboxylic acid. That is, this is ethanoic acid. Now this is ethanoic acid. Now, oxidation of alcohol to carboxylic acid, it is not done directly from alcohol to carboxylic acid, but it is done so far. For the first step, we have two steps. The first step is to form what we call it the aldehydes. And the second step is to convert that aldehydes to ethanoic acid by the process called oxidation. Now, oxidation takes place when this alcohol is converted to an intermediate product which is called aldehyde to produce what we call it ethanoic acid, which is a carboxylic acid. So there is no direct production of ethanoic acid from ethanol. This is something impossible. We must form, first of all, an intermediate product which is called aldehydes. So we may form anything. Now, example, propanol. This is propanol. Propanol can be oxidized to form what we call it propanal. It is called propanal. This is called propanal. Then it is oxidized also to complete what we call it carboxylic acid, which is called propanoic acid, which is carboxylic acid. This one, then it is carboxylic acid, it is formed. So there is no direct production of carboxylic acid from alcohol, but there is what we call it intermediates. Intermediate product which is called aldehydes, and then this aldehyde is then converted to what we call it carboxylic acid. So these are the very important things to understand, and this is among of the chemical properties of carboxylic acid. So we are having reaction with base and reaction with alcohol, but also we have oxidation of alcohol to carboxylic acid, which is done into two steps. The first one is to convert them into aldehydes, and then this aldehyde is oxidized to what we form carboxylic acid. And this is a very important process on how now we can prepare carboxylic acid. That's all about chemical properties of carboxylic acid.